Okay, so this is experiment 19, and we're going to be dealing with magnetism in this one. For this one, first thing you're going to do is you're going to take your magnet, and you're going to put it on the scale and figure out how much exactly that magnet weighs, so that you can use that as a baseline to compare for later things, which will tell you how much a magnetic force is. And then you're going to have this guy turned on, turned on, and then slip this guy around to right on top of the magnet with the red and black wires clipped onto it, so that they can basically send a current through this, which will be able to repel the magnetic field that this guy has produced around him. So then, once you put this guy in, you know how much force there should be due to gravity, just from the weight of the magnet itself. So then you can turn up the current by just kind of moving this guy around to go 1 ampere up at a time. And then each time that you increase the amperes, move this guy around to check what the new mass or weight of it is, when really that's going to be the weight of the magnet plus the force of repulsion between the current and the magnetic field produced by this magnet, which will be able to give you the force of the magnetic field if you graph it out, so that the added, it's called mass, but really it's just the force of the repulsion, and then you do that equals F equals ma to then get your, mg in this case, to then get your calculated force, and you can graph out current versus force, so that you can see as you increase the current, you're increasing the amount of force of repulsion between these two guys. And then that's part 1. And part 2, you're going to take this guy out and take this magnetic field sensor, which, if you look at it, actually can be at different angles because it's a bar inside. Then you're going to hold this guy right onto the magnet and have a protractor to see what angle it's at. Now, it's not going to be very accurate because you're trying to look at the angle here and the degrees are way out on the side, but you're going to try your best. And then on Data Studio, you should be able to see how much magnetic force there is at different angles. And so you can get your actual magnetic force B by doing B at perpendicular, which in our case was 0.005 Teslas, divided by sine of theta, theta being whatever angle you had this guy held at. And then to see if you were accurate in this one, and also once you increase theta as you go around, you can then get a slope, and you're going to, for B2, B1 was the perpendicular, B2 is you take the slope of all the different B's that you found as you were changing your angle and divide it by length. Length is actually length from here to here. To get B2, and then to check if you were accurate, you want to do B1 minus 20% should be less than B2, which should be less than or equal to B1 plus 20%. And if that is accurate, then you were successful.